Dear students, in terms of science, let's see what is an intensive property and extensive property. So, the word extensive has been derived from a word extent, which somehow indicates size. That means if the property depends upon the size of the sample, it is basically an extensive property. In short, we can say that extensive properties are size-dependent properties and depends upon the size only. While as size-independent properties are known as intensive properties. In other words, we can say is intensive properties doesn't change with the change in amount of the substance, and extensive properties change with the change in the amount of substance. Say for example, in this container we have a sample. For example, this is a gaseous sample, so that we can consider other properties as well. Why gaseous? Because in solid liquid it becomes a bit difficult, not impossible, but a bit difficult to consider all the properties. That's why we're gonna consider over here a gaseous sample. So let's consider some properties and see the difference between these properties. So as we have a kind of a basic property, that is mass, same volume. Similarly, we have another property, and that is pressure. And a really great example, temperature as well. So in this video we're going to see whether these properties are intensive or extensive properties, or we can say whether they are size dependent or size independent properties. So let's assume in this container we have a gaseous sample of mass m. Let's say m is equal to 500 grams. Similarly, let's assume that this container has a volume V. Let's assume the volume of this container is say for example 2 liters. Similarly, let's assume that the sample is exerting the pressure on each side of this container. Let it be it is P, for example. So the sample material is applying the pressure on each side of the wall. Let this pressure be 3 atmospheric pressure. Okay, so let the P be 3 atmospheric pressure. Okay, so this is a kind of a random this calculation, so you are not supposed to be specific about actually which gas we are talking about. Okay, now let's assume that we have another property, that is temperature, and that temperature is say for example 350 kelvins. Okay, now we are done with the first sample. Let's assume that we have this sample, and this is the exact copy of the above sample, but we gonna divide this sample into 2 equal parts by creating a boundary between. In this way, the sample is divided into 2 equal parts. Now we can see here that we have 2 equal parts. We have splitted one sample into 2 equal parts, and now here the mass is not gonna be m. Okay, it's gonna be m upon 2. That means the mass of sample A was 500 grams. Now it's gonna be 250 grams as per the sample number 2 is considered. Now we have 2 parts, and we're gonna see whether the property is size dependent or size independent. So it's evident over here that the mass changes with the change in the amount of substance, or we can say that it is size dependent, so it is an extensive property. Similarly, the volume of the sample A is 2 liters, and in sample B we have divided it into 2 parts, so volume is also gonna be V upon 2. That's gonna be V upon 2. So volume is also a size dependent property, so it is an extensive property. But if we closely see that if in sample A, okay, it is exerting the pressure P, no doubt we have divided the sample B into 2 parts, but it is exerting the same pressure on the walls from each side, and that pressure is P. That means the pressure is not size dependent, it is basically an size independent property, because the same pressure is exerted on the another part of the sample. So pressure is not a size dependent property, it is basically an intensive property which doesn't change with the change in the amount. So let's talk about the temperature. Temperature over here in the sample 1 is 350 Kelvin. So we have divided, no doubt, we have divided the sample 2 into 2 parts, but as pressure remained same, it doesn't change. Similarly, the temperature never changes. No doubt we have divided the sample 2 into 2 equal parts. So temperature is also an intensive property which doesn't change with the change in amount. Let's talk about another property, and that is density. So no doubt that we have divided the sample into 2 equal parts, but the thing is that no doubt we have divided the sample into 2 equal parts, but the density will remain the same. So here the density D is equal to 250 grams per liter. So density will remain same as per the sample number 2 is concerned. Okay. So here we can say that the density is also an intensive property which doesn't change within the change in the amount. So density here is an intensive property. We use some more properties as per the thermodynamics is concerned. For example, we have heat capacity is a property which we use in thermodynamics, and we have another property as per the thermodynamics is considered, that is specific heat capacity. So what is heat capacity? Basically, heat capacity is like if we are supposed to rise the heat of a sample, and that heat is supposed to be raised by 1 Kelvin. So to rise the temperature to the 1 Kelvin, we are supposed to provide the Q amount of heat. Okay. So to rise the temperature of this half of the sample, we are supposed to provide the half of the heat, that is Q upon 2. That means heat capacity is basically a size dependent this property, and it is an extensive property. So we need more amount of heat to rise the temperature of the bigger sample, okay, to 1 Kelvin. Similarly, if we have a glass of water and a bucket of water, we need more amount of heat to rise the temperature of the bucket to 1 Kelvin. So heat capacity is basically an extensive property. Why? Because it changes with the change in the amount of the substance, and it is a size dependent property. So in next video we're gonna talk about the specific heat capacity. Till then, take care. God bless.